All right, so we just have one example here, but maybe I'll do a few from the homework if that might help you a little bit to fill out a little bit more time. But this is example 5, and we have to use something to get an angle. And to get an angle is useful, like we could use law of sines or the law of cosines, but in this case, we're having to use the law of cosines because the law of sines requires one complete ratio of an angle and its opposite side, which we don't have any angles, so we have no ratio for an angle and opposite side. So instead, we're going to have to use law of cosines. So pick an angle. It doesn't really matter. You have all three sides to use, so any of the angles will be fine for a wrapper. So I'm going to just pick up this angle right here. We call it theta. All right, if you recall, in order to find that angle, we have to use second cosine, but step 1, we're going to take 23 squared and set that equal to 21 squared times plus 15 squared. Gosh, I have to remember what this is. Minus 2 times 21 times 15 times the cosine of theta, whatever that angle is, right? And then we subtract 21 squared and 15 squared from both sides. We get 23 squared minus 21 squared minus 15 squared is equal to negative 2 times 21 times 15 times the cosine of theta. And then we're going to divide both sides by negative 2 times 21 times 15. All right, and then our cosine theta is equal to, so we're going to do cosine inverse of 23 squared minus 21 squared minus 15 squared all over negative 2 times 21 times 15. All right, and that's going to give us that angle theta. That's equal to our angle theta. All right, so probably want to see again. I mean, you already did an assignment like this, but it's always good to see plugging that into the calculator. I'll just make sure it's seen here. So second cosine, and then put in your fraction. Second cosine with the fraction, so 23 squared minus 21 squared minus 15 squared all over negative 2 times 21 times 15. Arrow out, put in your parenthesis, and there you have it. The angle is 77.4. Now I would just leave that there, 77.4, leave it in your calculator. So we know this angle is 77.4 degrees. All right, and then we have the wrapper scenario that we need. We have the angle side that we need to find the area of that triangle, which is what we're looking for. So area is going to equal 1/2 times the sides, 21 times 15, times the sine of that 77.4 degrees. Okay. Now, again, in my calculator, where did that go? Oh, there it is. Okay, in my calculator, what I'm going to do, I already have the angle, so I'm going to do 0.5 times 21 times 15, and then sine, I'm going to go up after I've typed in sine, highlight, hit enter, so it will bring that angle in, put in my parenthesis, and that's going to be the most accurate because it gives us the entire part of it in the calculator, and that area, oh, it went away, but that's okay, 153.7, and this is square millimeters. Okay? And that's how you would use the law of cosines or in this. Now, of course, it's okay. We're just using the law of sines, law of cosines to get the wrapper to use for the formula. And I'm going to just do a couple. I like to put this up so I can see, where is that? So I know how much time I have left. Where did I do that? Oh, man. Gosh. I want to see it, but it's not letting me. All right, so we'll just try a couple here. Find the area to the nearest tenth. I wanted to do just a couple. Let's see. If I do 3 and 4, you think? All right, I'll do 3 and 4. So 4 is a little easier because it is just missing an angle in here in order for it to have our wrapper scenario, our side angle side scenario we need. We already have those two sides, and we have an easy way to come up with the angle. So we would just add 81 plus 43, and you get 124, and 180 minus 124. And that is going to be 56 degrees. So our angle is 56. And once we have the side angle side, we're good to go. And we can just set up 1/2 times the side, 34, times the other side, 49.2, times the sine of the angle between them, 56 degrees. Plug that in the calculator. 0.5 times 34 times 49.2 sine 56. I always check, make sure I put that in correctly. I believe I did. So this has an area of 693.4 square feet. Okay, not too bad. And then number 3, I picked it because it was a little more difficult. You do have to use the law of cosines in order to get that angle, any angle. You have all 3 sides. You have no way to set up the law of sines. So we have to resort to the law of cosines. So we'll do, I guess, that one right there. Let's find that angle. All right, so that angle is the side across from it, 23 squared equals 10 squared plus 17 squared minus 2 times 10 times 17 times the cosine theta. Right? So then we subtract the 10 squared and subtract the 17 squared from both sides. So we get 23 squared minus 10 squared minus 17 squared equals negative 2 times 10 times 17 times the cosine of theta. Then we divide by the negative 2 times 10 times 17. And that gives us cosine theta equals, so theta equals cosine inverse of 23 squared minus 10 squared minus 17 squared all over negative 2 times 10 times 17. All right, so in our calculator, second cosine, put in a fraction and just type it in as it is. Gives you less chance to mess up by performing any operations on your own. Calculator, do it all. Negative 2 times 10 times 17. And we get the area, that angle, theta, is 114.3 degrees. All right, we're going to use a different color. And we're going to use our formula, 1/2 times the side, 17 times 10, times the sine of 114.3 degrees. So again, you can use your information you already have typed into your calculator, times the sine 114, whoops. I'm going to not put in, I'm going to do sine and then extract that angle from my line above it. And I get 77.5. So area is 77.5 square feet. Okay, and there we have it. All right, hopefully that will help, and good luck with that. Have a good day.